So good morning to everyone. So welcome to the lecture number 3. So today topic is stress strain curve between the two material, that is mild steel and HYSD bar steel. The stress strain curve is nothing but it is a relation can be studied by drawing a graph between stress and strain. Okay, which means that the strain is drawn through the x-axis and the stress is drawn to the y-axis, and it is simply denoted as it is a stress strain curve. Okay, and this is obtained by the conducting the tension test in a building material testing lab of a standard specimen. Those specimens are either in the form of mild steel or HYSD. Mild steel is a low carbon content, that is low carbon steel content. Okay, mild steel, and which HYSD bar is nothing but it is a high yield, strength deformable bar. And these specimen, especially for the first one, mild steel, okay, and these specimens should be placed in a vertical in the UTM machine that will be conducted under a tension test. Okay, before the inserting the these specimen, okay, this is marked with the L1 that is gauge length, and a L2 is a final gauge length. Okay, and after the breaking the specimen, the specimen will appear like a cup and cone shape. Okay, this point is nothing but it is a necking point, that is in the form of cone and a cup shape. This is a breaking specimen, okay, after the conducting the experiment. Okay, it is very simple. Mild steel specimen ends are gripped into the UTM machine. Extensionometer is fitted to the test specimen, which measure the extension over length L1 from the figure A, and the length over which the extension is measured is called as it is a gauge length, and the load is applied gradually at a regular interval of a load. Extension is measured. After certain load extension, the increase at a faster rate. The load is increased at a faster rate. Capacity of the extensionometer to measure the extension comes out an end. Hence, it is removed before the stage it reached, and extension is measured from the scale on UTM. The load is increased gradually till the specimen break, which means that the loading unit should be increases gradually. Okay, and after increase the load, there must be a possibility automotive graphs installed in the machine, or you have to draw the graph separately. Okay, which means that the x-axis should be on strain values, y-axis must be on stress. Therefore, the stress is nothing but what it is a load by area, that is force by area. Okay, see here you have to understand this graph. The x-axis is strain delta L by L, strain is force by area. Okay, as at the initial the load is increases, okay, the strain value is linearly varies. The strain and stress values are linearly varies up to the point A. Therefore, that point is nothing but it is a limit of proportionality. Again, as the rate of loading is increases, okay, the material gets its hold the capacity up to the point B. Therefore, the B point is nothing but it is a upper yield point. When the load is decreases, the material come to its elasticity position, okay, to the point C. Okay, therefore the C is nothing but it is a lower yield point. Again, if you increase the rate of loading again, okay, there must be a sudden change in variation in the stress as well as the strain to the point of F. And then the point D is, it is a maximum capacity. Okay, that point is nothing but it is ultimate stress. Okay, ultimate stress. And then the material has loses its holding the strength capacity. Therefore, the graph is decreases towards D to E. But at the E point is a breaking point, which means that the material gets break and in the form of cup and cone shape. Okay, therefore you have to understand these 5 points. That is, point A is a linearly varies, that is limit of proportionality. B is the upper yield point, C is the lower yield point, and D is the ultimate stress, and E is the breaking point. Okay, and the point origin, that is O to A, is a linear, and the point A, that is the region between A and C, is called, it is a yield of proportionality. And when the region C to D is nothing but it is a strain hardening, because as the load increases, the strain is also increases, and the stress is also increases in the form of, okay, rapidly changes. Therefore that zone is nothing but it is a strain hardening. And when the point reaches to D to E, that is the failure under takes place, that is failure region, that is under a necking region. Okay, and these are the several points, especially for the limit of proportionality. It is nothing but it is a limiting value of the stress up to which the stress is proportional to strain. That is, at the initial, as the load increases, see, as the load increases, the sudden change in that is the strain is also increases, stress is also increases. Elastic limit in the material, okay, the elastic in nature, these limiting value of stress up to which the material is stressed, then a released strain disappear completely and original length is regained. This point is slightly beyond the limit of proportionality. And yield stress, the value of stress at which the material continues to deform at a constant load condition. And the next upper yield point B, this stress at which the load start reducing the, okay, and extension increases. The phenomena is known as, it is a yielding of the material. Okay, yielding of the material. These are the possible stress capacities. And a lower yield point, at this stage the stress remains the same, but strain increases for the same line. If you consider for the D, that is at the last one, ultimate stress. This is the maximum stress. Okay, the material can resist this stress up to 370 to 400 Newton per mm square. It is a possible standard values. Okay, and breaking point, of course, the stress at which the finally specimen fail is called as a breaking point. At this stage, the strain become 20 to 25%. Okay, and these are the ferrous and non-ferrous material stress strain diagram. Okay, this is a mild steel. If you consider for the cast iron, wrought iron, okay, mild steel, medium, this is a stress strain curve. If you consider for non-ferrous material, those materials are anneated copper, brass, and bronze, aluminum, and magnesium oxide. Okay, these graphs are very important, and if you go through any competitive exams or company interviews, they will ask the first question is, draw the stress strain curve of a mild steel, HYSD, and ferrous and non-ferrous material. Just you have to draw the behavior of the stress strain diagram. If you consider for the HYSD, especially for the high yield steel, see here, this is your curve. Okay, linear curve. Okay, in this the elastic materials, there is a no clear cut of a yield point. Here there is a no upper point and yield point. There must be linearly vary and suddenly reach the ultimate and suddenly decrease the breaking point. Okay, therefore the necking takes place at the ultimate stress is eventually at the breaking point is lower than ultimate. Therefore this stress sigma y, which is unloading, it made there will be a 0.2% of the strain. Therefore it is a 0.2 of a proof stress it is. Okay, this point is treated as yield point for at practical purposes. Therefore for a HYSD stress strain curve, the yield point should be a 0.2% of the, okay, 0.2% of the proof stress. If you consider for the brittle material, especially for the concrete, okay, the stress strain diagram will be a curve type, that is half curve type. Okay, and there must be a possible terminology, that is percentage in elongation. It is L dash minus L divided by L, that is length at a rupture, length at a failure, original length divided by L into 100. Okay, and for a ductile, the percentage elongation must be 20 to 25, and a percentage reduction in area, that is minimum that is original cross section area minus, okay, minimum cross section area. If you see here, at the initial there must be a possible dia, there must be a possible dia, that is, okay, area pi by 4 into d square, but under due to failure your dia must be on decreases. As the dia decreases means there must be a, okay, rupture area or failure area takes place under due to the tensile specimen. Okay, next, normal stress, it is also known as it is a direct stress. Of course, it is a load by cross section area. If you consider for the true stress, it is a load by actual cross section area. If you see here, okay, in practical the if you does not change out the rate of loading, the stress will be the diagram will be appear like a straight line, that is up to true stress. Okay, that type of stress is nothing but it is a true stress. Therefore the true stress is equal to load by actual cross sectional area. Okay, next, factor of safety, it is a ratio of ultimate stress to the working stress. Ultimate stress to the working stress, which means that, okay, in practical it is not possible to design a mechanical component or structural component stressing up to the ultimate stress because of reliability of the material, okay, or the resisting deformation which may obstruct the functional performance of the component, and the load taken by the designer is only estimated the load. Okay, and the ideal conditions are assumed to be an analysis of the boundary condition. Therefore we should consider the factor of safety is very, very important for the further design lifespan. Okay, therefore if you consider for the RCC or steel, okay, whatever your estimated loads are there, that should be multiplied with some factor of safety. Okay, therefore the factor for safety is vary with a different type of the material. If you are using for the steel structure, the factor of safety should be a 1.85, concrete 3, timber 4 to 6. Okay, this will end with the today's session, but the main outline of the today's session is, okay, you have to deal with only stress strain curve of the, okay, mild steel. This curve is a mild steel, okay, ferrous and non-ferrous material, it is a HYSD and brittle. Okay, therefore for the main exam or any interview they may ask the question on stress strain diagram of the mild steel. You have to explain those silent points, okay, and stress strain diagram of the HYSD and brittle. Brittle is nothing but it is a concrete type of the material. Okay, thank you. We will continue with the further classes.